Key features of an absolute value function. After this lesson, you will be able to define key feature vocabulary terms and identify key features of an absolute value function. So we talked about graphs before. Now we're going to be talking about the function. We know that there are standard forms of all functions. The standard form of a linear function is y equals mx plus b. The standard form of an absolute value function is y equals a, absolute value x minus h, absolute value plus k. Key features of an absolute value function also include the vertex. Remember that from when we went over the graph. It is the maximum or minimum point of an absolute value function. Now the change here is that it's located at hk. So we have this little hint to help you here. X always lies to you. X is always the opposite sign. So if I know that it's a negative h, I know it's going to be a positive h in my answer. So we're going to do A together. So first I've got to identify my h and my k. So my h is coming from negative 6. X lies to you. So instead of a negative 6, it's actually going to be a positive 6. And then we have our k, which is just positive 1. Notice how the sign changed for x, but it didn't change for y. So 6, 1 is the vertex of this function. Try your best finding the vertex of the rest of the examples. Go ahead and check your work and be amazing. We have negative 4, because the sign switches, and a positive 2. Negative 5, and a negative 9. We have a positive 2. This one might have tripped you up. If there's nothing here, it's like I'm saying plus 0. So my y value is actually 0 for that vertex. Same thing here with E and F. It's like I have x plus 0 on the inside. Because if there's x all by itself, we know that the standard form says x minus h. So we're going to have that plus 0. So my x values on both of these are going to be 0. And this one is negative 3. And this one also is like it's plus 0. So that's how we get 0 over here. So there's how you find the vertex from a function for absolute value. Next, we're going to talk about the axis of symmetry. The axis of symmetry, again, is a vertical line that divides the graph into two equal parts, like you're folding it in half. The equation is x equals a number, and this is the key part, where the number is the x value of the vertex. Well, we just figured out that the x value of the vertex is h, remembering that it's the opposite sign. So all I have to do is identify the h, which in this case is 6, was said negative, so we know we're going to use it as positive. It's an equation, x equals 6. I'm going to show you again, looking at B, we're looking at this h value. We want the opposite sign, so we're going to use a negative. Axis of symmetry is a line, so it's going to be x equals opposite sign, negative 4. Do your best to find the axis of symmetry for the rest of the examples. Check your work and be fantastic. So we have x equals negative 5, x equals positive 2, and both of the next ones are x equals 0. Because we know that this is like having x plus 0 on the inside. The next key feature we're going to talk about is the y-intercept. As we remember, it's the point where the graph intercepts the y-axis. It's found by substituting, so this is what we do for the function, it's found by substituting 0 for x. So everywhere I have an x, I'm actually going to put a 0. And then I'm going to just evaluate what we have. We have the absolute value, which kind of acts like parentheses, so we have to do it first. 0 minus 6 is the absolute value of negative 6. Don't forget, you still have the absolute value round the outside, plus 1. We're going to take the absolute value and get positive 6, because absolute value just takes away the sign, plus 1 equals 7. We write our y-intercept as a point. We know the x value was 0, and we got positive 7. So the y-intercept of that function was 0, 7. Do your best to try problem B. Check your work, B, awesome. So again, we're going to do what's inside here first. 0 plus 5 gives me the absolute value of 5. Don't forget those absolute value bars. Absolute value of 5 is 5 minus 9. We get -4, but we need to write it as a point where my x value is 0 to show that it's a y-intercept. Try your best on C and D. Go ahead and check your work. Be amazing. So here we have the absolute value of -2. There's nothing to do after, so we just take the absolute value and get 2 for the point 0, 2. Likewise with this one, absolute value of 0 is just 0. Minus 3 gives us -3. So we have the point 0, -3. And there's your y-intercept from the function. The next one we're going to talk about is the x-intercepts. X-intercepts, as you remember, are the point where the graph intercepts or crosses the x-axis. It is found by setting the function equal to 0. So this is where your first lesson on solving absolute value equations is going to come in handy. So we are going to say all of our y values are 0. And then we're going to take steps to solve for x. So we're going to do this first one together. We can't touch what's inside the absolute values until they're gone. So the first thing I'm going to do is subtract 1 on both sides. So I get -1 equals the absolute value of x minus 6. Now this might hurt your brain a little bit, so listen up. Can an absolute value equal a negative number? No. Absolute value will never give you a negative number. If I put something in, it's coming out positive. So if you get something that is not possible, then you know that there is no x-intercept. So again, an absolute value cannot equal a negative, so I have to go ahead and say that there's no x-intercept. It never crosses the x-axis. Try your best on B. Check your work. Be fantastic. So I know I'm going to add 9 to both sides because the 9 is outside the absolute value. That's going to give me the absolute value of x plus 5 equals +9. Now to solve absolute values, I need to write 2 separate equations. One where it equals the positive answer, and another where it's going to equal the negative answer. To solve both of these, I would subtract 5. But I'm going to get a different answer because my 9's are different. On the first one, x, 9 minus 5 is 4, so that's going to be the point 4, 0. And on the second one, -9 minus 5 is actually -14. So I'm also going to have an x-intercept at -14, 0. And so those are my x-intercepts for part B. Do your best to try C and D. So for C, it's kind of actually pretty simple, seeing as how I only have what's inside the absolute value. There's nothing being added or subtracted after. So I'm going to go ahead and write this twice. X minus 2 equals 0, and x minus 2 equals 0? Can you put a positive -0? No. So it's only one equation. So I'm going to add 2 to both sides, and that's how I get x equals 2 for the only x-intercept of 2, 0. For part D, I know that I'm going to add 3 to both sides, and that is going to go ahead and be 3 equals the absolute value of x. I set it up so that I have x equals the positive answer and x equals the negative answer. Since nothing was inside the absolute value, I already have my answer. 3, 0, and -3, 0. And there's your x-intercepts for part C and D. Great job getting through these notes. Go ahead and do your best on the practice for the lesson. And never, ever, ever, ever forget, you are awesome.